Okay, so this is another one of these. I mean, keep in mind all this whole sequence of questions is a highly guided and structured, thing. So stay on the path and do exactly as the problem suggests. So I am going to do exactly as it suggests here, and I'm going to take this equation, v equals vt. I'm going to differentiate both sides of the equation with respect to t, and then I'm going to see what happens, and I'll come back and after we've done that and see how maybe I might be able to connect that to these things right here. Okay. So for the moment, v equals vt, and that, and let's differentiate both sides of the equation. Okay. All right. Well, now notice I've got a vector that's a product of a scalar and a vector, and so I've got to use a product rule appropriately. And as is shown above, that means now if I take the t derivative of both sides, right? Of course, I get acceleration on the left, right? And then I get, well, let's see here, v prime t plus v dt dt. Cool. All right. Okay, and let me write little v scalar prime as dv dt. Okay. Now let's look up and see how we're doing. Okay, so we did the differentiating of that equation, and we were supposed to come up with tangential component being dv dt. Well, wait a second, what is the tangential component? The tangential component is the thing that you multiply by the t vector. Well, sure enough, look at this. Here's the t vector, and as desired, now we're not done yet, but that has shown up as the thing that you multiply it by. I can't quite get this all on the screen. There we go. So it's looking good so far, right? Pretty good. All right. Okay, but then there's this other term, and of course, we have to be sure we understand what this is before we can go anywhere. So. All right, so elsewhere in the hint, it says use the product rule. We already did that. And then rewrite that, namely that, rewrite that as dt ds times ds dt. Okay, I'm going to, again, do as I'm told. Let's see here. So I get... Okay, well, can't quite fit that all on at the same time, but dt ds times ds dt. Okay, so I get this. All right, now here's the thing. This dt ds looks familiar. Right? That is something we've seen before, and in particular, dt ds is kappa times capital N. Yeah. Okay, and that then gives me okay, let's see here. V kappa times capital N ds dt. Oh, now let's interpret for a moment here. What is ds dt? Well, ds dt, this is just v. Right? That ds dt is, how much distance per unit time. That's just speed. That's the magnitude of your velocity vector. So that I can rewrite then as dv dt t plus kv squared n. And that exactly puts this in the form of at t plus an n AT is that, and AN is that. Yeah. Everybody happy?